Good day, everybody, and welcome to today's webinar. This session will begin at the top of the hour.
Welcome everyone to today's webinar. I'm your host, Mike Lasecki, and joining us today is Dr. Brenda Koenig. Did I pronounce that correctly, Brenda?
It's canine, but close.
Canine, thank you. I should have got that. Thanks, Brenda, for taking over control. We just switched control of today's webinar to Brenda's machine because we're actually going to do a live demonstration, actually live, of how to use some of these remote science labs. Brenda, will you take us to the next slide? I'd like to introduce to everyone today, first myself, there you can see me on the right. I'm Mike Lasecki, Director of Maytech here at the Maricopa Community Colleges, and also joining us today as an additional discussant is Bob Ehrman. He's the Managing Director of the Nanotechnology and Career Applications Network, Career Knowledge Network, at Penn State University. Bob, welcome today. Why don't you say hello and tell us, how long have you been at NACK, by the way, Bob?
Ooh, over 12 years now, 12 and a half years. Was in industry before that, and now I'm here for 12 years. Long time. But by the way, I don't think I've ever been called a discussant before. I like that word.
Yeah, I like that term too. Well, thank you for joining us, Mr. Discussant. Brenda, please tell us a little bit about yourself. We can see that you're the lab manager and instructional designer at Great Falls College, Montana State University. Is your background in science or instructional design? What's your background like?
Sure. So I started out actually in chemical engineering. I have a bachelor's degree in chemical engineering and decided I wanted to go into the biological sciences, so I pursued a PhD in pharmacology. I then went to San Francisco and worked in industry for a little while before we moved back closer to home. I'm from the Montana, Idaho area, so we moved back closer, and I worked in a research institute here in Great Falls, Montana for about 4 years, and then transitioned over to the college about 3 years ago, where I built our robotic lab, which we're going to demonstrate for you guys today. And then I've also moved into an instructional designer role to enhance our online learning. So I kind of have an interesting background to getting to where I'm at the moment, but I'm really excited to get to show you guys today what we've done with our remote labs.
Well, thanks. I think that combination of educational background and industry experience is sort of unique. So we're very pleased that you're joining us today, Brenda. Why don't you go ahead and take us into the first slides, and then we'll see your demo.
Great. So today we're going to start with a brief introduction to NANSLO, which is our North American Network of Science Labs Online. We'll then go into a live demonstration of our equipment. We'll talk about some of our student data and some feedback we've gotten and how we've evolved since we started about 3 years ago. And then we'll give you some contact information if you're interested in pursuing utilizing our services or working with us on collaborative projects. So we're first going to start with what a remote science teaching lab is. So kind of down at the bottom, I've got the kind of traditional modalities of what we see for remote or non-face-to-face science delivery. NANSLO, we consider ourselves a remote laboratory, and so our definition of that is a physical location where real laboratory equipment resides. A lot of folks use virtual simulations. You can buy kits to send home with students. And I should also mention we are a 2-year community college, so our focus is primarily on those introductory chemistry biology courses. We have worked with K-12 systems all the way up through graduate programs though, so we do have some versatility there, but for our purposes, our main focus is that 2-year community college student, just because that's our institute's vision and mission. We control the equipment over the computer using an internet connection. So kind of the visual for this is if you have students or kids that you know of that play video games interactively online, that's kind of the model we're going for, that we're going to be using real lab equipment rather than controlling an avatar or a character. For our system, control can be either real-time, so students are physically controlling everything in a real-time situation, or we can do batch submission of parameters, especially if it's a piece or an experiment that's going to take an extended period of time. So NANSLO was built through a Department of Labor grant. It started in 2012, and we took a consortium approach to this. So we wanted to work together with other institutions to create some high-level, high-quality lab activities while leveraging knowledge of experts in their field. So we gathered a group of faculty together to decide what objectives and what lab goals we were trying to get with our students. This equipment, as you can imagine, is all robotics and lots of IT equipment involved, so there's a little bit of a capital cost to start with. So we wanted to leverage that by having a multiple node network for this. And we wanted to increase access to our students. So in Montana, we're a pretty rural state. We often will travel 3 or 4 hours to get to the nearest town. We have students that drive in 2 hours to get to class every day. So we're really trying to leverage that accessibility piece for our rural students. We currently have 2 network laboratories. We have one in Great Falls, Montana, which is where I'm located. So we're in north central Montana, kind of between Yellowstone National Park and Glacier National Park. The other lab is in North Island College. It's actually in Canada. It's on Vancouver Island, and they are similarly situated as we are with rural students. So this has been a really great partnership between the 2 laboratories. Okay. So our goals, we really want to make real scientific laboratory equipment available to students. We want to maximize that capital equipment usage. We also wanted to create really highly rigorous activities. We decided to use a network model for distributed asset reasoning and for durability. So if something would happen in the Montana lab, the Canadian lab could pick up the resources needed for the students. But really our main goals are real equipment to collect real data for real people. So this is a picture of our lab in Montana, and I'm sitting just behind where that picture would be taken. This would be the data that the students would gather, and then these are actually some of my students I've had in face-to-face classes who were kind of our first testers when we started the system 3 years ago. And so I was going to pause here for a moment before we go into our live demo and see if there was any questions or anybody had anything they wanted me to clarify before we jump in.
There is a question, Brenda. I'll take it first, and then maybe I'll ask Bob as well. But for the first question, one of our participants wonders, and you probably will address this, what happens if you get too many requests at the same time? How do you prioritize or manage that for student use?
Absolutely. And that would be, right now I'll say that our capacity, we haven't run into that problem, but we have thought through it. We have a built-in scheduling system with our equipment. So students are in charge of scheduling their own activities. Once a time slot fills up, then they're required to pick another one. And we have not had a capacity issue, and we will talk a little bit later about how many students we can serve and how that works too. But that's a great question. I would love to have that problem.
Okay, that's good. Bob, what about you? You've got a comment or a question at this point?
Yeah, are there, I wasn't quite clear. Are there people at the equipment, or is the equipment self-controlled basically by the student?
So we do want everything, the design is everything is autonomous. We do have a staff member that is in the physical lab. Should there be a technical problem, should there be something that would happen, but the goal is that this is all autonomous and students are driving their own experiences.
Great. There's another question here. If there's a large class, who gets to manipulate the equipment? So she teaches 11th and 12th graders. So I'm thinking that, is there one person that gets to do it, or multiple people? How does that work?
Absolutely, and I think that's a great segue into our demo. So I'm going to show you the equipment, and we'll show you how that works. So So let me switch my screen over. Actually, I'll show this slide first. So this is our interface that students would see pulling up on their computer or laptop, or we even have, for bigger classes, we've projected this up on like a screen in front of a larger class or in an auditorium. But the way our system is set up is that there is, on the right-hand side here, is our live video feed, which would show our equipment. So right now we're showing a microscope. On the left is going to be our controls for that piece of instrumentation. And then on the bottom right, that's going to be our video control. So students are actively engaged with the video as well, which we find to be really helpful for their engagement and their attention. And what they're seeing is actually the same as they would see in the lab. So this would be the microscope that's set up, and then that image is then sent to the students. So all of the controls, there are robotics attached to this microscope, which then translate over to the controls on the remote location. But they are seeing a live image of what's going on.
Can you go back one slide?
Sure.
So when you say the video controls on the lower right, what do you mean? I mean, there's like a video camera looking at the equipment? I just want to make sure I understand.
Yes, so we do have a live video camera. So there's a pan, tilt, zoom Sony camera pointing at, we have the background here would be the microscope slide, and then on the inset, that is actually the equipment, so the wide view of what's going on. And so I'm going to switch over to our image. So this is the live microscope image right now. So for the question about how students interact, we can have up to 25 students per piece of equipment logged on at a time. We actually encourage people to limit that to about 5, just to increase user abilities, increase user engagement. If you were doing this in front of a large class, though, this could be all put up on the screen, and then students could come up and take turns running it. But so the way that works is that the first thing you need to do is to actually request control of our system. So I actually had control of this already, but I'm going to request control of our virtual instrument here. And so what that's going to do is going to let me now have, these buttons are going to become live. So I can turn on our picture-in-picture. So this is actually our system, and I'm sitting directly behind it. So I'm going to come wave at you all, if you can see me. So that's the live image from the lab.
We saw you there. Go back, wave again. Wave again. I want to see you again. Okay, there you are. Okay, so this is really live, yeah.
So it is
all
really
right,
live. And then the fun part, I think, that the students really enjoy is that they can control that. So we actually have, it's kind of a running joke in the lab, is that they find the lab tech, so the students are going to zoom the camera around until they can see us sometimes. So they have full control. They can zoom out, they can zoom in. And sometimes to get students comfortable, we'll recommend that they look around and try and find the lab tech, who are often sitting off to the side. We have these preset controls that let them zoom in, so we can see that there is a slide on the microscope. Right now I've just got a general slide we use to explain field of view and depth to the students. But they can zoom in and zoom all around. The microscope controls are over here on the left. So they are moving the slides around. There's a focus. We have a coarse and a fine focus, and I'm gonna turn off the inset for a minute so that's not obstructing the picture. But students, you can see the focus changes here. So I think this is a really advantage of our system, is that students really are getting live data. They're getting live feedback of what they're doing. Coming from an industry standpoint, a student that can understand what's a good sample and what's not a good sample is a really important skill. And by having this be real data in real time, I think that really enhances their critical thinking and troubleshooting skills. We have different objectives. We can zoom in and zoom out with our objectives. We go up to 600x power on our microscope. We have the capability to go up to higher levels than that, but if there was a need for that, we could do it. For our general students, we don't generally do that because then that adds oil immersion and some other things that would make it a little trickier. Another really cool and key feature of our system is this capture image button down here. So you should see the image go blank 2 times. So what it's doing is it's saving a high quality photo of that microscope image. For our system, we actually ramp down the streaming from a 4K video down so that we're not using as much bandwidth. But students can get that full resolution image by capturing that image and then viewing that captured image here. This brings up a high resolution picture for them. This is then, they can save this to their local machine. So all students viewing this, so if everybody on this webinar was logged in, everybody could be viewing this simultaneously. Only one person is in the control of the system, but we can pass control around. So just like you would be in a car, if you stopped and passed control, everybody got out and switched positions, that new person would then be driving it. So if I had another student, they could come in and take over the system from me. We encourage group work. That is up to the faculty if they want to have students 1 or up to 5 per lab room at a time. We encourage the group work. I think you see some really interesting things happen when we have group work going on. You see more engagement, at least personally, anecdotally from my perspective, because I teach in a face-to-face class as well as help offer these online labs, is that I see more engagement on the online labs. And I don't know if it's because there's not that physical presence, but when we have students on the conference line or they are in our chat window, we see participation from the entire group rather than just maybe 1 or 2 of the more vocal folks in the group. Just to show that this really is completely independent, I'm going to request control again. We're going to turn that picture-in-picture in again. I'm going to zoom out. And then I want you to watch this. This is our robot that's going to pull slides from our tower. So I'm not physically touching anything. I'm just telling our robots to do it. So this is where the control from the student side comes in. So let's zoom in a little bit. You can probably hear in the background the arm moving.
I can hear the arm moving, Brenda.
Great. So the students then would get a list of slides that are preloaded. Right now I think I've got about 30 slides loaded. This is what we use for our general introductory to microscope lab, and that's the lab we're running this week, so that's why it's preloaded. We can have up to 200 slides loaded at a time though, so if we have an A&P class or something that's really looking at a lot of different things, we can do that as well. We also have an intro to engineering class that does some material science type things with this. They'll look at different crystal forms and some microstructures that we can see, at least with the microscopes we have. So we have a lot of versatility in what we can do with this. I'm going to go ahead and load. I think I'm going to load. I was looking for a kidney cell because they're kind of interesting. Let's load a spleen. So this is a piece of tissue that was a pre-prepared slide. We have a really interesting experiment going on right now where we've got some kids growing some mosquito larvae, and we've been putting them under the microscope. And these kids live 400 miles away, and they're in a high school, and they're doing this for a science fair project. So they log in every day and check the mosquito larvae through the cameras we have, and then we put prepared slides under the microscope for them as well, so they can see things, see what's going on. So you can see the slide loads up. You move it in place, and we can see that it's a little fuzzy, so the students would make adjustments for this. This is probably a blood vessel going through your spleen. But again, we see a lot of students spending time looking through things. You know, one thing we see in an introductory class a lot is that the technical piece of them trying to figure out how to look through a microscope and not see their eyelashes, and, you know, kind of that handwork, which is important, but that first introductory class, really we're wanting them to get concepts down like field of view and depth and how the objectives work and that sort of thing. And I think that when we put it into the remote lab like this, we actually take some of those barriers away, and we see students really getting the concepts rather than worrying so much about, hey, can I actually do this or that sort of thing.
Brenda, we'll interrupt right now with an interesting question, if you don't
Sure.
mind. So do you require or perhaps suggest some preliminary work to be done by the students, or maybe a YouTube video for them to watch, or any pre-work before they come in? Do you suggest that?
We do. We work with the faculty members for their individual students. We're pretty flexible, but we do ask that the students watch. We have introductory videos on YouTube, just showing them kind of orientation to the equipment. It's not absolutely necessary. The lab techs can do quick kind of orientations when people start, but we do find that students that do that pre-lab or that pre-video work have a little better experience. It doesn't take them quite as long to get up to speed, so they'd be jumping in immediately versus 5 minutes in. The other nice thing about group work is if somebody has done it and maybe somebody else hasn't, then that kind of works its way out in the group as well. But just like with a face-to-face lab, it's really hard to get students to do that pre-engagement work. I will say with the videos, we have more success than we do with, say, written questions. But again, we leave that part to the faculty member. We're trying to just assist the faculty member in getting their learning objectives and their learning processes ironed out through the technology, and we let the teaching or the instruction up to the faculty member. With that said, though, we do have pre-constructed labs that are on our website, which we'll post up here in a minute. And these are all free and available, open source, Creative Commons license, so anyone can grab them and use them or make modifications as they would like to them as well.
That's very valuable for an instructor. Bob, do you want to bring forward Christine's question? Unmute, Bob.
Let me get off mute first. There I am. Yeah, first I didn't mute. Now I did mute when I was. So anyway, what software do you use, Sarah, for this remote access? And does a user need to?
Brenda.
I'm Brenda. I'm sorry, Brenda. I apologize. And does the user need to install anything on their computer in order to use it?
That's a great question, and we've gone through several evolutions of getting to the point where now students do not have to download anything. So what they would do and where they would go is we just have a website portal. Whoops, I typed it in wrong. Live demo, right? Let me go back to...
The only time she makes that mistake is when it's live demoing, Bob. So.
That's right. And I'll just
We
skip
see
ahead.
you. We see what you're doing, Brenda. That's good. That's good. Yeah.
So I did make a slide to kind of explain how the system works. So an instructor would contact us, and they would reserve a time for the lab activity. We usually suggest a week to 2 weeks for you to open up a lab activity for students based on the number. Students then get an email with a link and a PIN number for that specific activity. So their lab is tied to a specific reservation that an instructor creates, and that's so that we know that that student is using that piece of equipment at that time, and they have it reserved for that. At that point, the instructor doesn't have to do anything. The students create an account and reserve a block of time that works for them. And this is all automated, so our system knows how many pieces of equipment we have, how many students we can handle at a given time, and it does this automatically once we set that first piece of the reservation in motion. Once students have made that reservation, they complete pre-lab exercises or watch introductory video on how to use the interface. We can make those available in your LMS system too, so we use Desire to Learn as our LMS, but we also work with folks that have used Moodle or Blackboard. And so we can create release conditions that maybe they can't sign up for a lab until they've done that, if you desire that. And then at the scheduled time, our system releases their account basically and lets them log into that site that I tried to type in and couldn't do live. So it lets them work collaboratively at that point, and at that point, all of the students signed up for that time log in. At the end of the lab, if there were issues or if the students did a really great job, if we see a student that was really well prepared, we'll make notes in the log, and then that log is available for faculty. So if you want to see if your student spent 5 minutes in the lab or an hour, all of that information is gathered and can be passed on to the faculty member should they desire it.
Great, great. There's that age-old question. How much does this cost?
I have a slide for that too, so we'll go to that. So we have a usage fee model, and we charge $10 per student per lab. We have several pay models. It can be paid for by the institution. We do student fees or student access code. We found that to be tricky because everybody's got their own kind of way that it works. So Montana, for instance, we're not allowed to change student fees except every 2 years. And then it takes another year for that to implement. So we're on a 3-year cycle. So if we wanted to implement a student fee for this lab, it would take us 3 years for that to get through. And if we want to use it this semester, that's not going to work. So for our Montana students, we actually do a student access code, which is like a publisher code. So that's what we do for our state. We do have users in Colorado that do institutional models where the class, if they've got a specialty class, we have a food science class right now with 6 students in it that's using it, and the institution just includes that in their fee, and then they pay us kind of through a purchase order. Our scheduling system also has an invoicing system built in, so once we've set up the parameters with your institution, it does that all automatically based on the number of students and the number of reservations you make. So we've set our price point at $10 per student lab. That covers our costs as well as it's comparable to the take-home lab kits, which our students buy. So that's kind of where that model came from. Was there more questions on that, or?
Well, there's another question. It's a great question. Is what types of equipment do you have? Is it just optical microscopes, or do you have other things besides optical microscopes in your stable there?
We do. So our major pieces of equipment are these 3 right here, and we have multiple lab activities that work with each of these. So we do have the Nikon Eclipse microscopes. We do a lot for our chemistry class with these spectrometers. So we do enzyme kinetics, we do Beer's Law, we do an emissions lab where they can see the spectrum tubes and see what the different elements spectral fingerprints look like. We have mini GC where we can do volatile liquids, so alcohols and things with correct boiling points. So we do have quite a few pieces of equipment that work. We've created from those pieces of equipment these different lab activities. So as you can imagine, most of the biology experiments are going to use the microscope, but we also use the spectrometer in biology to do like an osmosis lab or a diffusion lab. So we do have quite a variety of activities. For chemistry, we do, again, anything from Beer's Law to gas chromatography. For our physics labs, those are actually going to be delivered through our British Columbia lab. When we joined the project a couple years after the Canadian lab, we were focusing on the biology and chemistry, and so we don't have all of the equipment they do for the physics. We're working on getting that, but it has not happened yet, but we do have physics lab available from the Canadian lab. And of course, we're always willing to work on new projects. That's kind of my favorite part, is coming up with new ways to do things. Okay. And I'll go back to the demo, and I'll show you our other piece of equipment that I have pulled up. So this is our emissions lab. Again, same way. We've tried to keep our interfaces similar, so if students come back to us and use another lab, they're going to have a similar orientation. So again, we have our video camera here on the right. We're collecting data or doing controls on the left. Video controls are going to be down here. So students are going to right-click, request control, and then we can move things around again. And so this is our setup for our emissions lab. So this is something we do for electromagnetic spectrum and chemistry, where we've got spectrum tubes lined up here with different elements. We then have our robot with a fiber optic detector, which connects to our spectrometer, which is over here. So the spectrometer is this little black box here. So that's what the detection is seeing here on the left. So I'm going to turn on a lamp for you. And again, I'm across the room. I'm not controlling any of this live. I'm connected remotely. You can hear the robot move. And I'm going to zoom in on that lamp. So our neon lamp comes on.
Just lit up. I can see it.
And then when we click start over here, we're going to see the spectrum from that lamp come on. And I think I do this lab in class too, where we use spectroscopes, which are basically a prism and a box, and then I have them do it that way, and then I actually will have them log in and do this lab, and it's interesting to see how their perceptions change on the type of instrument or the type of detection we're doing, and it's kind of a really impactful realization for the students that, oh yeah, depending on what kind of instrument we're using, what type of thing we're doing, we see things differently. Again, with the data here, they can export it to clipboard here on the bottom. They could then do manipulations with that data. With the graph, we have these interactive features that let us zoom in. So if we wanted a student to zoom in on these peaks, they could do that. They can move it around. We have a cursor, so they could drag it around if they wanted to get a really accurate reading of that peak. That information shows up down here. Okay. We can zoom back out if they wanted to start over. And we have a pause and a start feature on this because our lamps need to cycle on and off, or we go through too many of them. But students are again in complete control. They can do the pass back and forth. I'm going to move it over to C. So right now we don't have the light on. We turn the lamp on and we see that peak show up. And this is a carbon dioxide lamp. So.
Brenda, I have a question I thought I would bring forward. Many of us on the nanotechnology side, of course, are interested in the material science aspects. I mean, we love biology, but we really like chemistry.
Absolutely.
Sorry. So we said, why don't you get a scanning electron microscope and then we'll join your thing. What would you say to that?
If I had the funds to buy one, I would have one. I would love to have a SEM. My PhD project was actually in nanotechnology. We were doing polymer design and delivery for new drug delivery. So I would love to have a SEM.
Bob, now I know why we've got Brenda on here, because she's really a nanotechnologist at heart.
I was just about to say the same thing, Mike. I knew there was a connection somewhere. That's great.
So, Bob, apparently this will work. If you have a SEM, this will work.
Yeah,
right?
absolutely.
You can have pre-made samples, and they have an operator assist available. Boy, it seems to work.
Absolutely, absolutely. You just have to be very careful about crashing it. That's the big deal about leaving it unattended is the main concern I would have.
Yes.
How do you handle that, Brenda?
That's a great question, and we do see slides get broken on the microscope once in a while if they crash them in. We do have stops enabled, and from a lab tech point of view, we do have a way to just take over the system from our end if we need to. If we see a student kind of going down a path where they're getting down that black hole and they're not going to get that robot stopped before it runs into the microscope and we break a slide, we can intervene and do it. And I'll say my lab techs are very well trained, and they can usually tell by how things sound if things are getting to that point, because they've been with me for a couple of years now. I did want to point out, I moved my video camera over. This is our cuvette system. It's a heated system, so we can do temperature-controlled samples. These are standard cuvettes. We connect our spectrometer through the automatic cuvette turret, and we can do up to 6 samples at a time with this. So we have a liquid delivery system that lets students pump, and we use iodine and starch for demonstration purposes to get the black inky stuff out that they can detect with the spectrometer. So the students have a couple of preset conditions they run through, and then we give them some unknowns, so they get to explore and try things. But we can do temperature control, we can do fluid delivery in small amounts. So a lot of different capabilities with this system. So, if there were no
Linda,
more...
why don't you, yeah, I was going to suggest, I know you have some, I didn't mean to have you jump ahead, but you have some data coming up about how this has worked, right?
We do. So I will jump back to the slides.
Well, while you're jumping back, Sarah, I think, is trying to work a deal with you, my friend Sarah, and she wants to know whether the science fair person, the science fair kid, is $10 per time slot, or would you give him a one-time fee, or is there a group discount? I think that's what Sarah's looking for right now.
That's so.
I'll put you on the spot.
I will say I have a soft spot for kids that do science fair because that's kind of how I started out. And I've actually have my boss convinced that if we have science fair kids, we can do scholar programs. And so we actually don't charge the science fair kids at this time because we don't have a huge number. So we can probably make a deal. So.
I'm sure Sarah will be very, very happy about. Oh, look at that! She gave us a yay.
Fantastic! Yeah, yeah. I had some really great teachers and some really great opportunities when I was a kid that really sparked my interest in science, and I really think it's important to pass that forward. And so we try as much as we can to do outreach and reach out to those kids that have to make opportunities happen for them. So. So this is some of our usage data. We started in the summer of 2012. Going forward, we've had a couple of location changes. So we've got some spots in the middle where we don't have much data. We have ramped up quite a bit. We're doing, the Great Falls Lab does anywhere from 300 to 500 students a semester, depending on what classes are being offered. But we can have up to 20 students per hour logged in simultaneously with no stress on the system, and we've done stress testing on our bandwidth and our delivery system because we don't want students to log in and not have a good experience. So if we did a 2-hour lab per day, we could do potentially 680 students a week. So we do have capacity to expand, as you can see. We also had a lab in Colorado that at the end of our grant tenure decided to not go forward. They had some changes in their administration, and they decided to go a different route. So with our current setups, we can do that many students. I also received the equipment from the Colorado lab a few months ago, and we have the capacity to even expand further should the demand arise. So we are looking for partners and looking for anyone that would be interested in utilizing our services. Our current student usage, we staff from noon to 8 p.m., but we do other hours if requested. Monday through Saturday, generally, lab sessions are 1 to 3 hours long. Some of our labs, like the gas chromatograph, are a little bit longer just because a full run on that takes 15 to 20 minutes. So it would be hard to fit 5 samples in a couple hours. We can have up to 5 students on a piece of equipment. We can have more than that. We've self-imposed that limit to ensure student engagement, so we're not getting groups that are so big that we're not seeing everyone participating. Kind of interestingly, I ran this data last year and thought it was interesting. Our most popular times are 4 to 6 p.m. and on Fridays and Saturdays being our most popular days.
I'm very interested in that statistic, Bob. So you have students at Saturday night at 5 o'clock logging in for their experiments. How does that make sense? I guess it does. The data doesn't lie.
That's not where I was. That's not where I was on Friday and Saturday night.
That's very interesting, Brenda.
And you know, I think part of it's our student population because we are a 2-year school. I think at a 4-year school you would see a little different demographic there. Most of our students have jobs and kids, and I think it's when they can fit it in, and maybe that's the easiest for them. But I think you're right. I would not have been probably doing a lab at 4 o'clock on a Saturday while I was in undergrad.
One thing. Quick question, and you said undergrad, and I think you said it was mostly community college. Is there any other universities, or mostly community college? And what's the geographic distribution of those? Where are they? Where are these people from in your users?
Sure. So the grant that we started this out with was a multi-state grant, kind of northwest. So it was Montana, Wyoming, North Idaho and in Colorado. So those are where predominantly our users are currently from, just because we started with them and we've kind of built up with them. We do have a cohort in Alaska that's used us. We have a group in Pennsylvania right now utilizing us, and that is actually a four-year university. They have a very small number of students, though, and it's for a specialty class. So we don't have a lot of four-year university participants as of yet. I am working with a school in Idaho to actually get some chemistry experiments running for their engineering students, because they're having such a problem getting their students through labs because there's not enough lab space, that they're looking for an external resource. So we're developing so a little more. Most of our labs don't have a lot of math or a lot of calculations in it, so we're beefing that up for them so that they can start delivering those for their undergrads. And these are like junior, senior level engineering students. So we can take what we have and adjust it to the level of students we need, or what the needs of the students are. But I will say most of our users are in the northwestern region, with Montana and Colorado probably being the highest number. I did want to share a couple of things. Go ahead.
Well, can I just make a comment? I just happen to be looking at your screen, student reviews, and one of them is from a healthcare initiative. And that reminded me, on your sample bank, there was quite a few histology slides. Boy, this just seems like such a great, okay, I'm not a biologist, but boy, doing a lab work on histology with the ability to move those slides around, it just seems like an ideal thing.
Yes, and the reason we have so many biology experiments is because we were part of the Consortium for Healthcare Education Online, and so that was the kind of the push for the chemistry and the biology labs to get developed. So that is why you do see more biology labs than some of the other ones. But the microscope work is fantastic. We actually offer a, kind of an open lab concept for our students here on campus. If they call in and we have a microscope available, they're welcome to use it from home, because again, we have students driving in a couple of hours, sometimes both ways, for classes. So if we have availability, we sure make it open to students to use.
Thanks. Go ahead then.
I did want to share some feedback we got. So in the first 2 years of us running our lab, we had a kind of a voluntary survey the students could take. We had about 50% response rate, so a pretty good response rate on our survey. And of those, 75% were positive. So students were really receptive to this experience. Having a lab tech in the room, I think, gave them some comfort, and so that was interesting that a lot of our positive responses were just having kind of that support in the room. The original plan was to actually make this fully autonomous and not just be able to walk away from it, but after seeing our students' feedback, having that presence, even if they aren't doing anything, was really important to them. So that's kind of was surprising to us at first, but it's proven to continue and be an important piece of what we're doing. I also wanted to share.
I'm sorry, I had a quick question for you, and it relates to the question about the malfunctions. I assume that has to do with that if they're not sure how it's working or if it's working, that lab tech could intervene. Is that what the deal is, or how does that work?
They can. When we first started, we had a lot more technical issues than we do now. We worked a lot of our bugs out, so we'd have a computer freeze and they would have to restart. I would say in the last 3 months, so since spring semester started, lab techs really are there to get people started, and they might give you a prompt or two, but for the most part, my lab techs sit in the lab and do homework, so it's a really great job for them too, because they're getting study time in. But having that presence in case something did happen seems to be really important to those students. I will say we have had some lessons learned, so if you guys are creating some of these labs, really read student feedback carefully. We had a few comments where it was like, we didn't know how to run it, we didn't know how to use it, and then the follow-up question was did you read the pre-assignment material or did you watch the videos? And I would say 90% of those students had not done that pre-work, which, coming from a face-to-face lab and seeing what my students do now, it doesn't surprise me that much. But when I first would read these comments, I'd be like, oh, why are they having such trouble, or why did they not like it? And then we kind of went through the rest of the questions, and we found that most of these students were not doing the pre-assignment work as well. But as you read carefully, we did make adjustments based on that data. So when I was requesting control, you noticed that there was a box around a button that said, when you want to request control, click here. Well, you actually don't have to do that. You can click anywhere on that gray area in the screen, and that used to be our instruction to students, but they had a really hard time with that. So what we did is we created that button, and we took lab tech input, and we took the survey input, and we actually made that adjustment. So it's really important to read those feedbacks and adjust if necessary. And it really did make our system better. And again, we asked, did they read the pre-assignment? Did they call in and participate? This student in this case did not, but we did make that adjustment. Again, here's our usage fee model. And then kind of wanted to summarize really fast, and if there was anything anyone wanted to see or additional questions they had, I think we were going to open it up for that. But we really feel that these remote labs are a great way to deliver these science labs. High-end equipment, these microscopes are comparable to what I used in graduate school. This is not something you'd find in a normal teaching lab. Because they're being run by the robots, the lifespan on them is much greater too, because they're not getting that hands-on physicality from students using it. The lab model we've tried to make as affordable as we can for both students and their institution. Our overwhelming response is positive, and we do have some preliminary data that we're in the process of writing up for a paper about student engagement, and our outcome assessment is on par, if not elevated above, what a face-to-face classroom, comparable face-to-face classroom would be. So I just wanted to, and then at the end here, this is my contact information and kind of our process if you're interested in using the system. You would contact me directly, and my email is there and my phone number. We usually like to do a hands-on demo for the specific institution with the folks that would be using it. Then we draft a contract or an MOU for a pilot and implement a pilot or start using it for your students. Again, and then our websites are located here. All of the labs, our write-ups are hosted on witchy.edu/NANSLO, which is another one of our consortium partners. And then our specific lab information you can find at elearning.gfcmsu.edu/NANSLO. So.
You know, Bob, I think this theme of real data, real time, it just resonates, doesn't it? Because in today's world, you know, like let's suppose you're working in industry, you're often operating something remotely or diagnosing something remotely. It's what you do, and you're giving the students that experience. That really struck me as I was listening to Brenda today, Bob.
I totally agree with you. I mean, it's this is excellent for you know, usage of your equipment there, and it looks like a nice nice opportunity, especially for those to get their hands on this type of equipment. Like you said, it's high-end equipment. It's not the typical laboratory microscope. It's something that, like you said, you used in graduate school. So this is a really neat opportunity, and some schools just cannot afford the high-end equipment, and this is a great way to get around that and get their students that experience.
Absolutely.
You know, Bob, go ahead, Brenda.
Oh, I was going to say, when I worked at a pharmaceutical company, and before moving back to Montana, and the conditions we were in, we were doing every robotic screening, so we were doing thousands of compound samples a day, and because of the clean room situations we were in, the equipment we were running was not physically in the same room with us at all. And so I think as we go towards more of those tech skills, having students that are comfortable with using something remotely, or the idea of using something remotely could be really valuable to them as well.
I really agree with that. It just makes so much sense. I mean, everyone online, I can just hear the wheels, Bob, right? They're spinning in their head. They're thinking, how can I get my XYZ piece of equipment going here? But certainly the idea of doing science labs online, Brenda mentioned early on, she didn't dwell on it, but shipping a lab in a box that you do in your kitchen, um, that's really not all that cheap, is it, Brenda, when it comes down to it, compared to what you're doing?
So our students, prior to having this resource available, were buying lab kits. It had, I think it was 10 labs in them, and they were around $250 just for the kit, and then you had shipping on top of it. So they were paying about $300 for a semester of labs. We've reduced that cost down to them to about $100 for an equivalent experience, and I would even say a better experience because they're getting that higher-end equipment. They're getting better data. Some of our lab kits for our microscope labs, they were using a magnifying glass, so it's not really even a comparable experience for them.
I have one other question. This is critical for today's students. Can they run this on their phone? I mean, it is a web-based app, right? Can they run it on the phone, or do they need a laptop or desktop machine?
It works better on a desktop or laptop just because of the size of the interface. We do have students that use it on tablets. With tablets, they can make it work. Clicking and touching are very different, though, from a programming standpoint. So if they do that, they do have to have a stylus or something that's going to be a little more defined than their finger. So we do recommend everyone uses a laptop or desktop, with the tablet being kind of an okay in between. It is cross-platform. We do not require any specific operating system or any specific internet browser to use it. So we use an underlying LabVIEW programming structure, and then we use a remote desktop applications through a Citrix receiver. So it's really cross-platform. It works on Apples, it works on PCs, Macs, I guess, and Linux machines as well. So we haven't had any issues with compatibility, I guess.
Cool. You know what, Brenda? I'm going to take the presentation back to you, from you, if that's okay, and I'm going to ask Bob when I adjust the screen here. Just a moment, folks. Bob, can you tell us a little bit about the remote access instrumentation that Penn State offers? Here are the slides, says Rain.
Sure. We've been doing this for a number of years, this remote access. Now, this is not something that is a fee-based service at this particular time, but I have some really good ideas coming from this webinar today. But we have a whole host of really nano characterization devices at sites all across the U.S. Right now we have about 10, and in the near future we probably will have 13 or 14 in the very near future. We've got some that are coming on board, and they're at many states all across the country. So you can go and onto our website at right there, that nano4me.org /remote access. Our center's home site is nano4me.org, and you can go to the /remote access or go to one of the tabs, remote access, and you can learn more about it. And really what it is to bring nanotechnology and into the classrooms across the country, and hopefully from local areas. Like in San Antonio, I know we have Josefina on right now, who's working with folks in the San Antonio region, and Ray, who's working with folks in Arizona, and then Christine, who's working in Seattle, and I'm not forgetting somebody else who's on here. But we have 10 different sites all across the U.S., and it's just a way to bringing it into the classroom. And we're doing actually an impact study on that this spring with our partner at Pasadena City College in California. So, what else did I miss on that, Mike?
Well, I have a question that's related to one of our chat window questions, Bob. You're at Penn State, it's Oscar that runs the equipment there, and he interacts with the students, right? He's on video. So Brenda, do your technicians interact with the students other than watching and listening? Do they have an interaction? They might make suggestions, or is it that? How does that work? So
we actually ask the faculty what their preference is before we set up a reservation. Yes. If a faculty wants the students to be completely independent, then we respect that. We just answer the phone and we say, you've connected in, your lab mates are in the room with you, you guys go ahead. if a faculty member is comfortable with us helping, we will do that too. My students are actually more computer IT students, and so for the science, they've picked up a lot of it since they've been working with us. But a lot of times it's just oh, maybe you should take the slide to the left a little bit, or kind of hints like that. We really try to leave the teaching or the inquiry to the students as much as we can. But they can help if the instructor is okay with it and the students ask a direct question, we will answer it, because we do have they are on a conference line and we are monitoring it while they're in the lab.
Right. Good
And our RAIN is not yet as fine-tuned as yours is, but we do have laboratories available for usage in classrooms at the high school and or community college and or university level. So you can go to that RAIN site and you can see them, laboratory guides, and we're constantly adding to that laboratory thing. But it's not as direct as what you guys are doing. It sounds like you have a lab that's already there. They go through it and they use the instruments there to basically get their deliverable for their classroom. If I hear you correctly.
Yes. Yep. That's typically what our faculty members decide to do. Yes.
Cool.
Okay. Well, Bob,
ours is not unmanned. Ours is manned.
Bob, I don't want to rain on your parade, but on the next...
Oh man, that was pretty bad. That was really bad.
Folks, this webinar has been recorded, and to access the slides, you can go to nano4me.org/webinars or NCI-Southwest.org, and you can see the links there. But really, we're going to send you these links so you don't have to copy anything down. Brenda, I'm going to actually get towards the wrap up here. I'm going to look at one of the comments in the chat window, and it says, "I find your remote lab really fantastic." I actually agree. I think it's neat of you to show the stuff for today. So thank you very much for being part of it.
Thank you guys for the opportunity to show you what we've been working on, and we look forward to hearing from lots of people.
So folks, help us pay the bills. I'm going to launch a survey now and just ask for a little bit of feedback, a couple of short questions before you run away about today's webinar. You'll still be able to hear the audio, but right now up in the on the screen, you'll see the survey that's come up. Please take a few minutes to do it as we conclude for today. Thanks for joining. Thanks for being part of this webinar. And we look forward to seeing you next time. Brenda, thank you again. Bob, good talking to you.
Yes, thank you, Brenda. Thank you, Mike. We really appreciate it.
Folks, that officially ends our webinar for today. Goodbye.